Welcome to today's lesson. Today we're going to talk about a one-way Anova using Jasp. We're also going to talk about using a post-hoc pairwise comparison analysis. Let's understand what our hypothesis is. First off, in an Anova, we're talking about 3 or more groups. Remember, with a t-test, we only had 2 groups. So in this case, we're looking at 3 or more groups. So our null hypothesis is that mu1 equals mu2 equals mu3. Our alternative hypothesis is that at least one of these means is not equal to the other. That brings us into what we call the post-hoc pairwise comparison. We're going to learn about this today also, where after we know if there's a difference between the groups, we can come back with a post-hoc analysis to find where that difference is. All right, so let's jump into Jasp. In order to do our analysis today, we're going to look at the age category. Now, recall on our survey that we had 9 options for the age. And it looks like about 5-year intervals. And so we don't want to compare 9 groups together. So what I did to start this analysis is I combined our groups into this age category, a variable. Inside the age category variable, I combined 3 groups of the 9. So our first group now is less than 30. Our middle group is 30 to 44 years old, and our last group is 45 or greater. To start in Anova, we're going to look at 2 variables today. We're going to look at how much sleep, and we're going to ask the question, do people of different ages sleep the same or different on average? And then we're also going to look at stress levels. So let's start with sleep. So we're going to go to Anova and then Anova. Now the first thing we want to do is look at our dependent variable and our fixed factors. So we're going to start with sleep, which is Q10_1. We'll move it into the dependent variable. That's our continuous variable. And our fixed factor is the age categories variable that I just created. So here's our age categories. We're going to bring it over. Now, in order to write our response, we also want our descriptive statistics. So let's focus in now on the results. The first thing is our descriptive statistics, and you'll see that the average hours of sleep for less than 30 is 6.6 hours. For 30 to 44-year-olds, it's 6.58 hours. And for 45 years and older, it's 6.61 hours. Now, notice that those are all close together, and if we come up to the top, we'll notice that the overall p-value asking if these means are all equal to each other is 0.816. So that tells us there is not a significant difference between the means. Now, let's explore also how do we write this in APA format. So again, our basic format is going to be the statistic. In this case, it's an F statistic. The degrees of freedom, the actual statistic, and then the p-value. Now, I do want to call out one thing quickly. Notice that our degrees of freedom here, we have 2 degrees of freedom. We have 2 and 510. So we need to include both of those with our degrees of freedom. Also, our F statistic is 0.204. So in order to write this out, I want to actually make my conclusion statement also. There is no significant difference between the age buckets. Less than 30, and then I give my mean. 30 to 44-year-olds, and again, I give my mean. And lastly, 45 plus, and I give my reported mean. And then I write my APA format with parentheses, F for my F statistic, my 2 degrees of freedom, 2, 510, equals my actual statistic, 0.204, and then finally my p-value, p equals 0.816. The next thing we want to look at is we're going to also look at stress levels across age buckets. So again, I'm going to go to Anova and then choose classical Anova. Once again, I'm going to grab my dependent variable, which is my categorical, which in this case, is my continuous variable, which in this case is stress. And then again, I'm going to choose my age categories. So notice again, we have our stats over here, but I want to bring in my descriptive statistics also. And now, Here's the key here. Notice again, our means, less than 30, our average stress is 30.88. 30 to 44-year-olds, our average stress is 29.44. And finally, 45 and older, our average stress is 27.7. Looking at our overall p-value, we'll see that our p-value is less than 0.001. This means, again, that this is a significant difference between the means. I'm also going to point out our degrees of freedom are 2 and 499, and our F statistic is 11.68. But focus again on, we know that there's a significant difference between our means of 27, 29, and 30. However, what we don't know is where are those differences. Is 29 significantly different from 30.88? Or is 27 significantly different from 29? Is 27 significantly different from 30? We don't know where the difference is. All we know is that there's at least one difference. Come back to this slide. Again, the null hypothesis is that all the means are equal, and the alternative is that there's at least one difference between the means. So somewhere in here, they're not equal. So we don't know where the difference is, but we know that there's a difference. So how do we find out where the difference is? Let's come back over to our options over here, and we're going to scroll down to where it says post-hoc tests. A post-hoc test is a pairwise comparison of each of the means. We're going to compare this group to this group, this group to this group, and then finally also this group to this group. In order to do that, I come over to post-hoc tests. Let me scroll down a little bit more. I need to grab our grouping variable and move it over to the column. And then right here, we have our different types of corrections. And again, what this is, it's a correction on the p-value since we're doing multiple testing. We're going to learn about that in class. Now, the two most common are probably 2 keys and Bonferroni. Generally speaking, I like Bonferroni because it's easy for me to explain to people. So I'm going to go ahead and switch over to Bonferroni. But again, all of these are accepted pretty universally. The 2 that I see the most often are 2 keys and Bonferroni. But what is Bonferroni? Notice down here that when we select the post-hoc test, it gives us this post-hoc test output. And again, I want to point a few things out. First off, we have this pairwise comparison. We have the less than 30 group compared to the 30 to 44-year-olds, and we have a p-value. Again, we have the less than 30 group compared to the 45 plus, and we have a p-value. And then finally, we have the group 30 to 44-year-olds compared to 45 plus, and a p-value. The thing to note is that this note down here says the p-value has been adjusted for comparing a family of 3. And what that means is that in the Bonferroni adjustment, they take the original p-value and they multiply it by the number of pairwise comparisons. So if you have 3 groups, you're going to have 3 pairwise comparisons. So the original p-value was actually 0.058 divided by 3. And what they did is, for the comparison, they multiplied each of these p-values by the number of 3. Now, with this adjustment, we can now look to find out where the significant differences are between the groups. Again, remember, we're comparing to 0.05. So the less than 30 group compared to the 30 to 44-year-olds, the p-value is greater than 0.05. So therefore, there's not a significant difference between these two groups. However, comparing less than 30 to 45 plus, notice that we have a significant p-value, less than 0.001. So these two groups, less than 30 and 45 plus, are significantly different. And finally, the 30 to 44-year-olds compared to 45 and older, our p-value is 0.01. And that is significant. So what does that lead us to conclude? That leads us to conclude that the 45 plus group is significantly different. 27 is significantly different than 29, and 27 is significantly different from 30. However, 29.44 is not significantly different from 30.88. So that's our ultimate conclusion. Thank you.